Hi, this is a quick video on how to solve questions like 11, 12, 13, and 14 from the Analyzing and Solve worksheet. If you had class on a B day, which would have been 312, these were the questions that you did with your group in the back of the board, but a few people in the A day classes were just asking, what do you do to solve these higher polynomial equations? So in question number 11, I always start by just graphing this equation. So I'm going to pull up my calculator and graph. So again, I plugged in that equation from question number 11 on the worksheet right into y equals. Then I'm going to hit graph. When I hit graph, I see that it actually has one rational x-intercept at y equals negative, or x equals -2. Again, I can hit trace to sort of guess and check. Yep, it's a x-intercept. Or you can do second trace 0 to find it officially. But I know it's -2. Okay, so now I'm going to take that and go back to my worksheet. So from my graph again, I knew that one of my rational exponents is x equals -2. I'm going to take that and I'm then just going to synthetically divide into this problem. When I synthetically divide into it, again, I get 1, -2, 0, 0, 11, -22, 0, 0, 24, -48, excuse me, and 0. And this becomes an x to the fourth plus no x's to the third, 11x squared, no x's, plus 24 equals 0. Again, when you have these higher polynomials, again, we only found one root. That must mean that this polynomial is factorable. And I should recognize that an x to the fourth can be split apart into x squared. And I can think of values that add to 11 and multiply to 24. And then that allows me to solve. So x squared will equal -3, and x squared will equal -8. And what that tells me is that x equals plus or minus the square root of 3i, or I squared of 3, and x equals plus or minus I square root of 8, which actually can be plus or minus 2i square root of 2. And again, I can kind of go in any order. So that is 1, 2, 3, 4, 5 solutions. In question 12, when you try to graph this one, there is no rational root. And so this is just something, again, people have asked about, what do you do with something that has an x to the sixth? Well, really, you should notice that there are 4 terms. And when we had 4 terms in first semester, you could factor by grouping. So factor by grouping. And what that means is when you look at these first 2 terms, you should recognize that they have an x to the fourth in common. And we went over this in our little conference today if you joined. The second 2 terms have a -4 in common. And then what you notice is that your parentheses are the same. X squared plus 5 is the greatest common factor between those 2 terms, leaving you with x to the fourth minus 4 sort of as your not common factors. Again, that's my common factor. That's why I can list it here. When I solve this, again, x squared will have to equal -5. So x has to equal plus or minus I squared of 5. That's why that didn't show up on my graph. In this one, this is actually a difference of squares, x squared minus 2 and x squared plus 2. And then again, that means that x squared equals +2. So x equals plus or minus the square root of 2, not rational. And then this becomes x squared equals -2, square root that plus or minus I square root of 2, not rational. So if you tried to graph it, you're not going to see any of these values as rational because this is the only one that's real, but it's irrational. And so some people just, again, asked, what do you do when you have polynomials of higher degree? You can try, I always try graphing, but maybe I could try factoring by grouping. Thank you. If you have other questions, keep emailing and posting them. It went pretty well.